Okay, so what we're going to learn now is called systems of equations, which means that we're going to solve more than one equation at the exact same time. And there's three different ways to solve a systems of equations. The first one is graphing. The second one is called elimination. And the third one is called substitution. The one we're going to focus on today is graphing. You can use a graphing calculator, or you can graph manually. We're going to do both. But what we need to know is that when you graph the two equations, what you're looking for is where they intersect, where they cross over on each other. And every two lines intersect at exactly 1 point. And that 1 point is going to be our solution. So let's take, for example, that these two equations were our problem. Notice that one's in standard form and the other is in slope-intercept form. I could find the x and y intercept of the standard form and graph that one that way. Or I could change it to a slope-intercept form and graph it using slope-intercept form. This one is already in good shape. I don't really need to do anything to this one. But what we're going to do is I'm going to graph it with a graphing calculator just to show you what the solution is going to look like. Okay, so I went out to Desmos.com, and Desmos is a really nice, easy graphing calculator. A lot of the graphing calculators, like if you have an old, well, when I was younger, you had to have everything in slope-intercept form, or else it wouldn't graph it anyway. So it really wasn't that much of a benefit. But now, Desmos, you can put it in any format. You can leave it in standard form. It'll graph anything. And notice that the first equation they graphed using a red line, and the second equation they graphed using a blue line. And where they intersect, when you tap on it, it'll show you what the point is. So this is the solution here. X is 0.6 and Y is 3.6. That actually is the answer. We don't have to do anything else. The hard part about systems of equations with graphing is when you manually graph the equations. Otherwise, it's really simple. If you use a graphing calculator, it's probably the easiest thing that you could do. But we're going to manually graph because we need more practice anyway, and, this is part of math. But you can always check yourself with Desmos to make sure you're getting them correct. And especially if something is very difficult, you should always use this as backup so that you don't get discouraged. So let's go over some more rules when it comes to systems of equations and graphing. The one thing that you need to know is that if two lines don't intersect, then there won't be any solution. And if the two lines are actually the same line, like one lays on top of the other, then there's infinitely many solutions. So when you're looking here, if they intersect at all, there'll be one solution. Because they're always going to intersect in exactly one place, 1 point, and that 1 point is the answer. This only happens when they have different slopes. If they have the same slope, then that means they're parallel. Like here, the lines are parallel. These two equations, I don't know what the equations are, but I know their slope is the same. Let me show you an example of two equations that have parallel slopes. So let's say it says y equals 4x plus 1 and y equals 4x minus 3. Those two equations are parallel because they both have a slope of 4, but they have different intercepts. So this one's going to pass over at positive 1, and this one will pass over at -3. These would be, these two equations right here, as soon as you see this, you know there's no solution. They are not going to pass over, they're not going to cross over each other at all. They're not going to intersect. So parallel lines are always no solution. Infinitely many solutions would be that the two equations are actually the same thing. And sometimes they're easy to see. Other times they're a little tricky. So I'll show you an example. Let's say it said y equals 2x plus 3. And then the other equation said 3y equals 6x plus 9. These two are exactly the same equation. One is just being multiplied by 3. And when that happens, when you graph them, they actually look like one line. One's laying on top of the other. So if you find when you graph that they actually have the same points and that they're laying on top of each other, or it just generates the same line, then you know that there's infinitely many solutions. Typically, what happens is that they cross over once and they have one solution. This is the most common, but the other two are possible, so you need to have your eyes out for them and know that it's a possibility. Alright, so let's try some of these. Let's just look at number 1. Number 1, the first thing that I notice is that they don't have the same slope. This one has a slope of 1, and the second equation has a slope of 2. So different slopes, they're definitely going to intersect. So I'm going to go ahead and graph these. Alright, so we're going to go ahead and just start with the black one. And I'm going to count up 7. So 1, 2, 3, 4, 5, 6, 7. So there's my first point. And my slope is 1, which means 1 over 1, which means I rise 1 and run 1. So I run 1 and rise 1. So there's my other point. And I could do it again if I wanted to. And now I'm going to try and connect these dots. I don't think I'm having very much luck. Alright, well I know that's definitely crooked, but we're going to do our best. Now the red one, I go up 1. There's my first point. And then my slope is 2 over 1, which means I rise 2 and run 1. So run 1, rise 2. I'll do it again. Run 1, rise 2. And I'm going to connect those dots. And it's actually going to intersect off of the screen. So I can't tell where they're going to intersect because of the way I graphed it. So I'm going to check myself with the graphing calculator. Okay, if I had more graph paper, I would be able to see where they intersect. But we're just going to go ahead and graph it on the graphing calculator. And I went out to Desmos and I graphed those two equations, and they cross over at 6, 13. So my answer is x equals 6 and y equals 13. Those are my solutions. So we're going to check this one more time. I'm going to show you another way to check yourself. So my first equation is y equals x plus 7. Well, if x equals 6 and y equals 13, does that work out? Well, 6 plus 7 is 13, and that equals 13, so that one's good. The second equation was y equals 2x plus 1. Well, if y equals 13 and if x equals 6, does this work out? So I have 2 times 6, which is 12, plus 1, and we're still trying to see whether that equals 13. Well, 12 plus 1 is 13, so 13 equals 13. It works out. So another way you can check yourself is if you plug the answers back into both equations do they actually make the equation true? If they make the equation true, meaning that you get down to the end and both sides are equal, then you know you have the right solution. So what we want to do is I want you to finish the other two problems and these problems using Desmos online graphing calculator. We will practice manually graphing the equations with a different assignment. But these, I really want you to go out to Desmos.com, and it's DESMOS.com, start graphing, and then enter the equation. If you don't know how to do it, or if you need help, raise your hand and I'll help you get started.